Hi, I'm Carlton Coffran, and this is the second video in 3 short presentations which myself and Tim Heidel made at the PES General Meeting in 2016 to kick off the task force on benchmarks for validating emerging power system algorithms. Now, this video is about the implementation. How are we going to make this happen? Now, when you're building a new set of test cases, there are many questions you have to ask yourself. How should the test cases be hosted and disseminated? Should it be an IEEE publication? Should it be a website, a code repository, or an email list? What format should the test cases be curated in? You have SIM, PSSE, PSLF, map, power. There's lots of options. How should copyright be dealt with in the test case archive? And how should test cases be organized? Now, I have a lot of opinions about how this should be done, but I don't want to be the only voice. I want the community to believe in this initiative as well. So I organized a web discussion before PES with the following 5 volunteers so that I could assemble a concrete plan that we had agreed on at this particular meeting. The outcome of that discussion had 3 main results: some recommendations for how we disseminate and curate these test cases, some clear signals on how we should copyright them, and then some observations about a forthcoming grid data program. And I'll go through each of these in detail. First, dissemination and curation. This group decided that the test cases should be hosted on github.com. The reason for this is that GitHub has all the same functionalities as hosting on a website, but it also has additional features for community collaboration, keeping track of changes over time, and it's free. So it's a sustainable model for a volunteer effort like this. So how will this be organized on GitHub? We'll start with a homepage, which is very similar to many other homepages that covers the background, the introduction, and the contact information for this particular effort, but quickly the homepage will start linking to problem-specific test case repositories. There might be one repository for AC optimal power flow, another one for AC state estimation, and then one for stochastic unit commitment, and so on. So what did these problem repositories look like? At the base, they're just a list of files. It's a website which behaves just like a folder on your computer. You can click through the directories or even click on individual files, and it'll show you the textual description of that file in your web browser, and you don't need to download anything at all just to browse what is going on. Now, from my previous experience hosting collections of test cases, 90% of users will just want to download everything, and this green button allows them to easily download all of the test cases which are in the archive. Now, the site provides a lot of other additional features. For the sake of time, I'm only going to mention 2. The first one is this Issues tab. This is a little tab where anyone can make a suggestion for how to improve this repository. It's also a place where the curators of that repository can manage the work they want to do in the future and communicate that back to the community that certain improvements are underway, although they might not be finished yet. Now, the next feature has to do with collaboration. So let's assume the task force has an ACOPF repository that's official and curated by the task force members. If a researcher comes along and they decide they want to make a bunch of modifications to this version, but they don't want to get approval from the task force, what they can do is called a fork. Fork will make a personal copy of the task force repository in their account, which they can modify and make any changes they like without affecting the official gold standard copy. Another researcher might come along and also make their own personal fork and then make other modifications. And all of these forks are tracked by the system, so you can see how the information is being distributed and disseminated amongst all these different people. Now, at some point, researcher 1 might decide that the improvements they've made could be very valuable to the community at large. And GitHub provides a feature called a pull request, which begins a dialogue between the master repository, which is the task force in this example, and the personal copy. And after a long discussion of coming to some consensus, the task force and the researcher agree on what the changes are, and then with a click of one button, all of that researcher's changes can be merged into the task force master repository to share with the whole community. And this whole process can be formalized and tracked through the GitHub system, and this provides a complete trail of all the data evolution. So in this example, you're seeing for another repository 3 different entities which have taken different copies of the master repository, which is indicated by the dark black line on top, and the arrows indicate when the information was forked and then merged back in to the master repository. The next major issue that came up in this discussion was copyright. And this is very important to enable the kind of collaboration we were just talking about. So before I can tell you what the decision is, we need to cover some of the background of what the copyright spectrum is. So there's basically 2 extremes of copyright. On the left-hand side, you have all rights reserved, which you've probably seen the little C in a circle, which clearly indicates this copyright. And in this example, you have a very restrictive copyright where everyone must ask you explicit permission to use your work, and you can say no for any reason. You really own every little bit of it. The public domain is on the other end of the spectrum, and it's the total opposite. You need no permission. No one needs permission to use your work, and no one can stop you from using it for any reason. Usually after 100 years or so, artistic works enter the public domain. Now, these 2 distinctions made sense before the internet era, but post the internet era, we've realized we need much more fine-grained control of copyright. A good example of this is the Creative Commons. This has emerged as a new standard for giving fine-grained control of copyright. And whether you know it or not, you've probably already used Creative Commons because Wikipedia is based on this very idea. And this is what enables, in a legal way, for everyone to collaborate on Wikipedia and give it back to the world. Now, Creative Commons is internationally robust and it gives you fine-grained control. So you have to decide exactly what kind of Creative Commons license you want. At this meeting we agreed that we would like to go with an open access data through the Creative Commons BY license. Creative Commons allows redistribution, Creative Commons BY allows redistribution and modification as long as the original authors are acknowledged. That means who is the work by. Now, what were our motivations for this? Firstly, Creative Commons BY models the academic ethics we are all used to. It's fine to borrow ideas as long as you cite the original source. Secondly, Creative Commons BY is already adopted by IEEE and others for open access publications, so it's in line with what the journals are doing. Last but not least, RTE, the French network operator, has released real French transmission system data under Creative Commons BY. This is setting a precedent that real data can be released using this kind of a license. So for all these reasons, we decided that the test cases should be released with this copyright. The last point that came up in this discussion was the fact that the grid data project by ARPA-E is coming. We're expecting in the next 1 to 2 years new repositories, new problems, and new data coming that will all be very valuable to this kind of effort. So it was recognized that we should watch these projects closely and potentially integrate or migrate to them as necessary. But it was also noted that we should start now with tools that are available. So we'll be watching this space, but we can start using GitHub right away. To watch this space closely, we have submitted a panel session proposal for PES 2017, where we would like to invite all of the grid data team members to give presentations on their work so we can follow it for this particular effort. Now, the most important thing about this whole effort is it needs to be community-based. We need you. There's no way this will be sustained unless many people get involved. So what are the different ways you can get involved in this task force? First off, you can simply be a user of the data sets that are produced and hosted as part of this task force. Simply using the data raises its profile and gives it value. So that's the first level of commitment. The next level of commitment is that you can participate in roughly quarterly meetings to review and share your thoughts on task force decisions. So by doing this, you will help shape the results of the task force effort into things which the whole community likes. And it only will take a few hours a quarter. The highest level of commitment is to actually be a curator, and this may take a few hours a month. The curator's role is to actively work to collect, encode and verify test cases, effectively curating a particular problem set of data. So let's get into a little bit of detail about what this curation role entails, because this is where the real value of the task force is created. I would also like to note that I believe ideal candidates for this are PhD students or early career researchers, because it's at that phase in your career when you're very close to the data and you're very well read in all of the related works to a particular problem. So if you want to become a curator, first you need to pick a problem domain. So for example, AC optimal power flow, AC state estimation, stochastic unit commitment, pick your favorite problem. If there is already a repository for that problem, you need to join the team of people who are currently curating that problem and work with them to expand its scope and make it better. But if there's not, you have the opportunity to select a format for encoding the test cases that you think is best for the community. Once you've picked your problem and you know your format, you can start data collection. You begin by collecting small seminal cases from the literature, but if you really want to get ambitious, you could try to get some real data from real industry. You encode that into some kind of a consistent format, which was selected already, and you ask the copyright holder for permission to release this new version under Creative Commons by. Once you've gotten all those steps, you're ready to publish it on GitHub. Now, this may sound like a lot of work, but if you're currently doing research and development, you actually have most of this in place already. You need to test your algorithms on lots of different data sets, and you've already found the ones you want to test on. So you're already at least halfway there, maybe even 3/4 of the way there if you're currently working on this problem. So we need your participation. Please get involved. The easiest way to get involved is to go to this particular web link and then put down what level of involvement you'd like to have. Would you just like to receive news? Would you like to join the meetings? Or would you like to curate a particular data set? And then if you want to nominate other people to be curators, because maybe you know somebody who's perfect for the job, there's another type of link where you can suggest particular people to be curators of particular problems. So please go to that link to recommend people there. Thank you very much for listening to this presentation. I hope you enjoy the third and final installment.